Hi class, welcome back. And so let's dive straight into the correlations lesson. Hope you're doing well. Correlation, as you probably know, is a measure of association between two continuous variables. And it can range from -1, which is perfectly negative, to 1, perfectly positive. And the closer the correlation is to 0, the weaker the association. And so here's a positive relationship, or positive correlation, and then here's a -1. And so if you wanted to visualize correlations and what they might look like depending on both the direction and the magnitude of the correlation coefficient, then here's just a little overview. Now, something that's important to note is that there are many different types of correlation coefficients. And so you're most used to probably looking at Pearson's R, and we'll talk about that specifically in just a few moments. But that is for two continuous variables, and there are other correlation coefficients that you can use if you don't have two continuous variables, and I've listed the types of variables that are required. So the main takeaway here is that there are different kinds of correlation coefficients. Now let's talk about Pearson's R, which is the most frequently used, arguably, in psychology. And it indicates the linear relationship between two continuous variables. Now keep in mind that this looks at only linear relationships. And so if there are, for example, U-shaped relationships or any other curvilinear relationships between two continuous variables, then you can't use this correlation, but that doesn't mean that there's no association. Now correlation, Pearson's R, right here, is equal to the degree to which x and y vary together divided by the degree to which x and y vary separately. Putting it into mathematical terms, it looks something like this, where xi and yi represents the x and y values for a particular case, and then y bar and x bar represent means for those variables. And so essentially you're taking the difference between your point and the means for both x and y, multiplying them here and then summing it up in the numerator. And then here, you're squaring the difference and then taking the sum, squaring the difference and taking the sum for the y, and then taking a square root of all of that once you multiply those two. Easy peasy. And so this is the degree to which x and y vary together, and then here is the degree to which x and y vary separately. So let's take a look at an example together, and this time we're gonna take a break from our Psych 300 dataset and look at a separate dataset for this demo just to have you see a simpler example, and then maybe you can apply what you've learned in this lecture to your own dataset. And so let's say that we have this research question. Is mindfulness associated with better psychological outcomes? And so behind that study, there's a survey of 161 real-life US college students, and they took an online survey administered on Qualtrics. And here are the variables in the dataset. In terms of the independent variable, which is mindfulness as a construct, was operationalized in two different ways. So awareness of one's experience and acceptance of one's experience. And so there are two different variables representing mindfulness, or facets of mindfulness. And then the outcome was measured as perceived stress. And so feel free to download the dataset and follow along, since you will be asked to run your own set of correlations on the same dataset after this lecture. Now let's take a look first at the two-tailed example. So the null hypothesis may be written as, there's no association between awareness and perceived stress. And then the alternate hypothesis would be that there's a significant association between awareness and perceived stress. So of course these two hypotheses are the opposites of each other. If you write it in population notation, then rho is the population version of the Pearson's R, or correlation. And so null hypothesis expression would be that rho equals 0. There's no correlation. Correlation equals 0. And then the alternate hypothesis would say that rho is not equal to 0. So it's significantly different from 0. Now let's talk about how to test this hypothesis in RStudio. In RStudio, you can use the core.test function in order to obtain your correlation. And for the two-tailed hypothesis, you're testing for a significant association. And so you can do that by using core.test, and then inside there, you tell it those two variables that you're trying to test the correlation for. X variable, in general, would be your independent variable, if you're thinking about it that way. And then the Y variable name, which would be the name of your dependent variable, and then a comma in between to separate the two. And so that's what R needs in order to run this correlation. And so let's hop on over there and take a look at how this works. So welcome to RStudio, your favorite. And I have set up my working environment where I have set my working directory and then imported the dataset mindfulness. And if you would prefer, please go ahead and do the same so that you can walk through this with me. Now, the first thing that we wanted to do was to run that two-tailed correlation. Now, just as a note, I have attached the dataset mindfulness, so I do not have to use that information anymore. I can just type in my variable name. And the hypothesis was that there is a significant association between awareness and perceived stress. And so we're looking at awareness as one of the variables, and then stress as a dependent variable. And so I give R those two variables, and let's try running it. So here's the core.test. Here we are, and so we've got our result for our correlation. Now all the information you need in order to evaluate your hypothesis is packed in here. First of all, take a look at the p-value. And so it is less than 0.05. And so do you retain or reject the null hypothesis? You might have said reject, and that would be correct. The degrees of freedom is for a correlation n-2, and so that's something that's useful to know. So there are technically 161 cases, and you can actually see that information in the environment over here. 161 cases minus 2, and so that is the degrees of freedom. You will need this information in order to write this up in APA style. And if you jump down over here, here is the correlation coefficient, or R, and so it is 0.258 if you round to the thousandth place. And so let me show you in PowerPoint how to write it up. And so here's the example. And so participants' awareness in the present moment was significantly associated with their perceived stress levels. And here is the way you write out the results. And so italicized R, and then there's no space, immediately starts off with a parentheses, and then the degrees of freedom goes in here, space equals space, and then here's the correlation coefficient. Just happen to round it to the 100th place, so 0.26. And do note that correlation coefficients never go beyond a -1 and 1, and so by APA style, you would not put a 0 before the correlation coefficient. It starts with a decimal point, so decimal point 26, comma, and then space, and then italicized lowercase p to indicate the p-value. And in this instance, the p-value was so small that it's less than 0.001, and so you would notate it as such. And just a friendly reminder once again that your degrees of freedom is n-2, so 2 less than your sample size. Now let's think about a one-tailed hypothesis. So let's imagine that based on theory, we expect an inverse or negative relationship between awareness, which is supposed to be an aspect of mindfulness, and perceived stress. Now stand to reason because there are mindfulness-based stress reduction techniques out there that are empirically supported. So if you are working on increasing your mindfulness, perhaps your perceived stress would go lower. And so with that assumption, you might have a set of hypotheses like this, where the alternate hypothesis would say there's a significant negative association between awareness and perceived stress, with the assumption that awareness is a facet of mindfulness. And so the more mindful you are and more aware you are of your experiences, the less stressed you are. And then the null hypothesis says the opposite, and so there's no negative association. And so the opposite of the alternate hypothesis. Now, when we write it in terms of the population parameter, so again, rho is the population version of R, correlation coefficient, the alternate hypothesis would say rho is negative. So your hypothesized correlation for the population would be negative, less than 0. If you look at the one-tailed null hypothesis, the opposite of this would be greater than or equal to 0. And so now both the alternate and the null hypothesis have a sense of direction. Now when you get to RStudio, we are still working with our friend core.test. And much of the function will look very familiar to you. So you provide R with X variable name and then Y variable name. But now we have a new statement to add after comma that starts with alternative. And so alternative equals, and then in quotation marks, less or greater, depending on your hypothesized direction of the Ure effect. And so in our example, we're expecting a negative association, so we would use alternative equals less. And that says to our test the hypothesis where the correlation coefficient is less than 0 or negative. If you were to hypothesize that there's a positive association, in other words, correlation coefficient is positive, then you would put alternative equals greater. And that would allow you to test that hypothesis. So let's go back to RStudio and try running it together. Okay, and so here in the code, I have written down some notes for you just to jog your memory should you be using my code. But in this instance, we have awareness and stress, but we're proposing or hypothesizing a negative correlation. And so again, we would tell R the two variables that we want to study, and this time we want to say alternative. And then in quotation marks, less, because we're expecting a negative relationship. And so let's try running that. So here we are, and we've got the result here with an incredibly large p-value. You usually do not see a number such as this. And R helpfully tells you that there is an alternate hypothesis you're testing, which says that true correlation is less than 0. So once again, we hypothesize that correlation would be less than 0 or negative. And so this is what we get. And then here's the correlation coefficient once again. Now p-value is much greater than our alpha 0.05, and so do you reject or retain the null hypothesis? We retain the null hypothesis, and so our alternate hypothesis is not correct. So let's take a look at how to write this up once again in PowerPoint. And so here you have it. So participants' awareness in the present moment. So awareness was not negatively associated with the perceived stress levels. And then once again, we've got the same notation as before, R indicating that correlation, italicized lowercase with parentheses containing degrees of freedom right after it, space equals space. And then this time I rounded to the thousandth place, so 0.258. And then p equals 0.995. Now, usually for p-values, I would do 100th place or 1000th place. But in this instance, the quantity was so large that if I rounded to the 1000th place, it would have been 1, which doesn't quite work. And so I just wrote it out. An important reminder, you've heard me say this a few times already, but in APA style, if you have a quantity that cannot be beyond an absolute value of 1, so it is always between -1 and 1, then you need to omit the leading 0 before the decimal point. So make sure that when you write a correlation coefficient, then it starts with a decimal point. Same thing with the p-values. And so as we wrap up, I wanted to just put a note in here that correlation does not equal causation. I'm sure many of you have heard of that before. And so our world is full of associations that are just spurious. For example, if you want to stop global warming, become a pirate. Or there's an uncanny correlation between the number of undergrads and injuries related to falling televisions. And so be careful next time you're walking around on campus, because you never know when a television might fall on you. Or for some reason, poisonings and Ben Affleck films are quite highly correlated. I'm not sure what to make of that. But here's some good news for all of us. Apparently eating pizza cuts cancer risk. Ooh! Now all kidding aside, just be careful not to read causation into correlation, even though this makes it sound like a lot of fun, doesn't it? Okay, so now that you've learned how to do the correlations in RStudio, it is your turn to try running it. And so using the same dataset as the lecture, please obtain correlations to answer the following research questions. Number 1, is non-judgmental acceptance, so that would be the variable acceptance, significantly associated with perceived stress levels, or the variable stress? The other question is acceptance negatively associated with perceived stress level? So once again, hypothesizing that maybe another facet of mindfulness, in this instance, acceptance, may be negatively associated with stress. And so go ahead and run your correlation test in RStudio, and then let me know what you found out. And wishing you a great day today. I know there's a lot going on, but I'll be thinking of you and rooting for you. And so here's to hoping that your day, your week, your semester, your year, they all turn out to be a reasonably good one. Take care and talk to you soon.